Some cool stuff coming up here, guys. I'm gonna sort of step a little bit off track and show you how options can work here and talk a little bit about the design process. And then we'll get back on track with actually developing this one a little bit. But what I wanted to show you here is that while we set a static, meaning fixed, domain, that can actually be variable. So if I was to, if you go under math and domain, remember we, at one point we actually deconstructed a domain and reconstructed it. Well, if you go to construct domain and you look at what its input values are, you'll see that it asks you for two numerical values. And those are the minimum and maximum numbers. So if you hover over A, it says the start value of numeric domain and the end value. And it borrows the same predefined properties, 0 and 1. So for me, if I'm going to override this, and I know, I figure I probably want my scale factor to be anywhere from 0.01 to 1, but I don't quite know what I want it to be exactly yet. So I'm going to say I want it to be 0.01 to 1, and I'll plug that into A, and then I'll copy that and plug it into B. And see here it's borrowing the properties of the input, saying domain start and domain end. You can rename that and say, scale minimum, scale maximum, or something like that if it's clearer to you. But if I put my domain end at 1 and I override the t, now if you watch closely on the perspective view here, as I increase the domain start, my minimum tiles actually will increase in size. So if you only want a little bit of slippage, you pull the domain start down just a little bit and you'll get a little bit of fenestration on the facade. If you want a lot, you pull it down a little bit farther. So that's how a domain is operating in this case. I don't know if I showed you that in the 2D version, but if it works in 2D as well, it's exactly the same. Okay, so that's for scale. I'm going to group this whole thing, and we're gonna actually take this down a notch here, and we're gonna copy and paste a few components down and begin to explore the surface boxes in another way. But what I want to begin to operate on is probably everything up to the box volume. I'll also want the closest point, and most likely the centroid. So I'll copy everything up to that point. So I'm going to copy everything up to and before the remapping and the scaling. And I'll paste it and pull it down. So remember, you probably should take a moment to drop in a few notes. You could pull up a panel and write some notes about what this is. So this is scaled twisted boxes to Attractor, something like that, to help you remember what was going on in each one of these when you come back in.
And up to what did you copy down there?
Up to right after we have boundary volume, I kept my centroid and the closest point.
Okay.
What you should have below should look like this. And I'm going to turn off my resultant here and look at what my box volume is that I'm now working on. All right. So with this box volume, I'm going to do something that's a little bit different. Well, yeah, I'll probably borrow properties of what's above too. So in this case, I'm going to scale. Well, do I want to start with that? Yeah, I'll start with that. So I'm going to scale geometry that's on top of the surface and simply create a textured surface. So I'm taking you away from the tower, and now we're looking at it as an assembly of texture rather than something that is an assembly of a building system. Okay, so if you're trying to create a wall panel that's twisted and it's got bumps on it, this is essentially what you would look at for this exercise. So instead of grabbing the centroid of each geometry, I'm going to grab the centroid of the front face of each geometry. So that looks a little bit different. I'm going to keep this up here, and I'll keep the CP down there. But I need to actually pick all of the front faces. So again, that's under Sets, List Item, and you can plug the faces into the list. 0 to, if there's 6 sides in a cube, you want this to go to 5. And you plug that into I. And let's take a look. At 0, I have the back face. At 1, I have the bottom, side, top, side. And at 5, I've got the front face. So using that, I can override the connection to the area geometry, and now it's giving me centroid values. If I turn this off, it's giving me centroid values on each of those surfaces. And then if I wanted to graft another geometry on top of it, all you'd have to do is grab whatever geometry that is. So if I say I want spheres, I want a little half hemisphere that's grafted onto this surface. Go into Surface, Primitive, Sphere. No, not that, sorry. Actually, yes, that. And it's going to ask you for the base point and the radius. So the base point is essentially going to be each of the centroids. Simple enough. See how it's putting them on there? And the radius for me, I'm going to borrow this property from above, is going to be the scale factor. So I can recopy it. It turns out I actually need more of this than I thought. So I'm going to recopy this geometry down here, or this set of nodes down here, to my new geometry. And if you recall, and you can see here that the D value will actually be plugged into the boundary and the V of the remap. So we can override those. And then it's very simple to just take the R value and plug it back into the radius. And this probably will give us not what I'm looking for, apparently. Oh, right, because these don't have a maximum size. Yeah. Surface primitive. Borrowed. All right, so in this case, I think what I would wind up doing is scaling. Yeah, it's probably just got to be a scale factor. Yeah. Remap. Don't remap it to that. I'll remap. Just a sec. All right, yeah, so rather than doing a scale function, I think what would make sense to do here is to change the domain end. So the domain end, if you recall, is actually, you know, if it gets plugged through remap, it'll actually be a multiplication. So if I increase my domain end, and I'm just going to go up to 25 because I don't know how big it's going to need to be, we can manually begin to scale up the size of the sphere until it almost fits the entire cell. The trouble in this case is that we can't really find, well, you can if you wanted to go through a whole bunch of math and distance calculations and everything, the exact radius of the maximum domain. Actually, suppose we actually could, but it'll be troublesome because you don't know which side, depending on which surface it's going to go on.
Does
So
this still use the same attractor point?
it does, yeah. So it's plugged into the same attractor point. So when I turn off the area and the list item surface, this is what you're going to see. And I can also increase the number of subdivisions. So increase the U count to 25. V count, yeah. Actually, that messes with my size of the sphere. So I'll leave it there. Bring my domain down a tad so those don't intersect. Good. Okay. So here's what we have. I have those spheres, and I have this box volume. And what I want to do is join the two so that I get one contiguous surface that has the texture of the spheres on top. And so I think if I use under intersect, shape, solid union, I wonder if these will communicate in VREP. Solid and sphere, they should, maybe. So if I plug in those solids and these solids, maybe it'll work. Yeah, cool. So I'll turn off these original ones, and this is what I get. It's one contiguous solid for each of the subdivisions. Looks like this bottom one was a little too big because it's kind of cutting through the front and back a little bit. But if I bake that, you'll see why it's significant. So bake it out.
How do you bake?
Don't worry about it right now. We're going to talk about baking a lot in the coming days, but I don't want you to worry about it right now. So I'm just trying to show you this real quick.
Where's the boundary volume?
Bound what?
The volume?
Oh, boundary volume. That's going all the way back to the deconstruct BREP. That's the original boundary volume that we copied. So the reason, guys, that this is significant is that now that whole thing is a one poly surface, and it's as if you did a Boolean union on these surfaces. And you could actually join all of them together too, but trouble is with twisted boxes, the edges don't always line up. And I really don't know what happened to these. Interesting. Okay, so let me get rid of that. I don't want those. So I'm going to leave this up for you to explore and get caught up. And then we'll move on to another option. Let me clean it up as well.
Is it set union or set? Should be.
Solid
No, wait, we don't need that there.
union is under intersect
I didn't want
shape.
just which one? This one?
Okay.